Hello all, welcome to UPSC with Sukumar. So in the previous videos we have completed the explanation of chapter 2, right? So after completing chapter 2, now we are starting with chapter 3, that is the interior of the earth. So in this NCERT chapter 3 itself, the sequence of the concepts that he explained in the NCERT is: first, the NCERT mentioned the sources through which we will study the structure of the earth or the physical or mechanical behavior of the earth. So what are the sources through which we can study the earth? And then after explaining the sources, he explained the earthquake. And then after earthquakes, he explained regarding the structure of the earth. And after explaining the structure of the earth, he explained regarding the volcanoes. So instead of going in this sequence, I thought that if we start with the structure of the earth, and then after understanding the structure of the earth, if we can study the sources through which we understood the structure of the earth, and then after studying the sources, if we can study regarding the earthquakes and then the volcanoes, it would have make more sense. So that's why, and it will be help in forming the conceptual flow also, more conceptual flow, better than the sequence that is followed in the NCERTs. So first I will explain the concept of structure of the earth. So now we will start with the structure of the earth. So the earth which we are seeing today is divided into different layers, right? Different layers, different concentric layers. Concentric layer means, that means one ring after the other, one layer over the other. Suppose this is the inner core layer, inner core region of the earth. Then comes the mantle region and then the uppermost crust region. So these are the layers that are located one over the other. That's why we are calling them as the concentric layers, right? Based on the physical or chemical properties of these layers, the earth is divided into crust, mantle and the core region, which is also divided into outer core and the inner core region, right? The crust is made up of solid silicates. The crust is in a solid state and is made up of silicates, and the mantle is made up of viscous, that means semi-solid molten rock, because of the temperatures, because of the temperature and heat that is present in the core region, and that heat is being transferred to the mantle region from the core region. So because of that, the rocks present in the mantle region will become viscous, right? And then the outer core, which is liquid in nature, and then the inner core, which is a dense solid. So based on these properties, it is divided into, the earth is divided into different layers, that is crust, mantle, outer core and then the inner core, right? So if you can see in this image also, this is the earth, right? So as we go inside like this, we can see first one is the uppermost one is called as the crust, the second one is the mantle layer, and the third one, that is the outer core, and the innermost one is the inner core, which is solid in nature, outer core is liquid in nature, and the mantle is viscous in nature, and the crust is a solid one. So that's how the earth layers are differentiated based on the physical or chemical properties. So after that, based on the mechanical behavior of the earth, we can divide the earth into different layers, that is lithosphere, asthenosphere, mesospheric mantle, outer core and again the inner core. So what is this lithosphere? Lithosphere is the crust plus uppermost crust plus uppermost mantle region. So in the image, if we can see, let's say this is the crustal region, right? This is the crustal region, and this one is the uppermost mantle. So these two layers combinedly called as the lithosphere. lithosphere. And after that we can see the asthenosphere, which is the uppermost viscous mantle. So in the image also we can see the asthenosphere, right, which is the uppermost part of the mantle. And then below the asthenosphere we can see mesospheric mantle, and then the outer core and inner core. Outer core is in liquid form and the inner core is in solid form. So we can understand, like I will explain the reason for the liquid nature and the solid nature of the outer and inner core also in the later part of this video. Okay, so we will understand the one by one layers right now. Now we are understanding the layers of the earth one by one. So the first one is the crust layer. It is the outermost layer of the earth and is having almost 0.5 to 1% of the total earth's volume. And density of this crust is 2.7 grams per centimeter cube. And the thickness, if you see, suppose let's say this is the earth, right? This is the crust region. This is the continent. And let's say here water is present. This is the oceanic region. Okay, so when we see the crust, the thickness of the crust, let's say this is the thickness of the crust, right? Till here the crust is present. When we see the oceanic crust, right, oceanic crust, let's say this is the ocean, right? So the below part is the first part is, let's say, is called as the oceanic crust. So when you see the oceanic crust is somewhere around 5 to 30 kilometers, oceanic crustal region. And when we see the continental crust, this is more than the oceanic crust. The thickness of this oceanic crust is less than the continental crust, right? The thickness of this continental crust would be 50 to 70 kilometers. So from this image also we can say that the thickness of the continental crust, the crust of the continents, is more than the oceanic crust. Fine, thickness. So and as we go deep inside the earth, suppose this is the earth, right, and different layers inside. The first one is the crust, right? So if in case we travel from surface to the inner regions of the crust itself, the temperature will increase as we go inside the crust. So the temperature will increase with the depth of somewhere around 30 degrees centigrade per kilometer. That means if we travel 1 kilometer deep into the earth, we can say there will be 30 degrees increase in temperature. And the composition of the crust. The crust is the outermost covering of the earth, right, and is made up of sedimentous rocks. So initially the rocks which are majorly formed are igneous rocks and the metamorphic rocks, right? These two, the first one is the mainly igneous rocks, is directly formed from the mantle that comes to the surface of the earth. So by disintegration or the weathering of these igneous rocks and the metamorphic rocks, we can say the sedimentary rocks will be formed. So the outer covering of the earth is mainly made up of sedimentary rocks, and these rocks are made from the igneous rocks and the metamorphic rocks. So below are the metamorphic and the igneous rocks, below the sedimentary rocks. And the lower crust is made up of basaltic and the ultra basic rocks. So when we say the continental crust is mainly made up of the granite, light silica aluminum rich rocks. So and when in case of the oceanic crust, it is mainly made up of basaltic rocks, which are dense in nature and is made up of iron and magnesium rich minerals. So if we see the continental crust, it is made up of mainly the silica and aluminum rich minerals will be present in the continental crust rocks. But in case of oceanic crust rocks, we can say iron and magnesium rich rocks will be present. So what is the meaning of this felsic and the mafic? Rocks which are rich in the feldspar and silica, those type of rocks are called as the felsic rocks. And the rocks which are made up of magnesium and iron, those sort of rocks are called as the mafic rocks. So felsic rocks are rich in silica, aluminum, sodium, potassium, like those sort of minerals, and the mafic rocks are rich in iron and magnesium. And Sial means silica and aluminum. So mainly the continental crust is made up of Sial. That means the continental crust is mainly composing of silica and aluminum. But if in case of the oceans, we can say it is mainly made up of silica and magnesium. That we call them as seema rocks. Fine. So that is regarding the crust. And most abundant elements of the earth crust are oxygen by the percentage of weight, right? And then comes the silicon, and then comes aluminum, like in this manner that we can see in the table, right? And the most abundant element of the earth percentage by weight, right? So here we are just saying exactly regarding the earth crust, but here all of the earth we are talking. The highest amount of elements that are present on the whole of the earth is iron. Then we can say the second one is the oxygen, right? So in this manner we can say. So next, so after crust what happens? We would enter the mantle, right? As we go deeper. So before going into the mantle, we can see the Mohorovicic discontinuity. Mohorovicic discontinuity. So what is this Mohorovicic discontinuity? So the crust is made up of some metals, right? It will have some density and it has some solid nature. So when we are traveling and when the mantle starts, mantle is made up of semi-solid or viscous liquid is present in the mantle, right? So the boundary that is present between crust and the asthenosphere, which is the upper layer of the mantle, right? So Mohorovicic discontinuity is a boundary between the crust and mantle. And why are we calling this as a discontinuity? Because when we are coming from the crust to mantle, there is a discontinuity. That means the solid nature or the properties, physical or chemical properties or the mechanical behavior of the earth is changing from one layer to another layer. The changing is there. The properties are not continuous. The properties are changing. That's why we are calling it as a discontinuity or change in the properties of the earth, right? So because the change is caused by composition between the feldspar rocks present in the crust and the non-feldspar rocks present below in the mantle region. And we can see these changes immediately. We can identify the sudden change in the properties based on the seismic waves velocity. So we will definitely understand the meaning of seismic waves, meaning in the earthquakes part. So just for sake of understanding right now, let's just say seismic waves help us understand the sudden change in the properties or behavior between the crust and mantle. So because of this seismic waves only, we understood that there is a difference in the composition of crust and mantle, and that's where the Mohorovicic discontinuity is present, right? It acts as a boundary between the crust and mantle region, the Mohorovicic discontinuity. So in brief, we can say that Mohorovicic discontinuity is a region which is present between the crust and mantle region, from where the chemical or physical or mechanical properties of the crust will change and new properties will be present in the mantle region, and this Mohorovicic discontinuity acts as the boundary between these two, crust and mantle. So that is what. And next is the lithosphere. What is lithosphere? Lithosphere is the crust plus uppermost mantle region is called as the lithosphere, and it is the rigid in nature. So it's not liquid, it is solid in nature, lithosphere. So the lithosphere itself is broken into different tectonic plates. So what is the meaning of different tectonic plates? We would understand in the part of plate tectonics theory, right? In detail we would understand regarding this plate tectonics in the plate tectonics topics. And just for the sake of understanding right now, let's just say that the earth is not a continuous body. It is, the crust is divided into different plates, right? And these plates will float on the asthenosphere layer. Okay, asthenosphere layer, above which lithosphere is present. So this lithosphere is only the consisting of plates, where the earth is divided into different plates. The lithosphere is itself divided into different plates. So because of which plate movement happens, right? Because of the fluid present under this tectonic or the lithospheric plates. So suppose, let's say this is the lithosphere. Sorry, just wait. So let's just say this is the crust, mantle and the core region. Crust region, mantle region and the core region. So crust plus uppermost mantle, this is the lithosphere. Okay, and because of the mantle, which is liquid in nature or the semi-solid in nature or viscous in nature, the plates, the lithosphere is divided into different plates, right? Different plates, and these plates will float on this mantle layer, which is semi-solid in nature. And while these plates are moving, there will be folding, there will be faulting, and because of which mountains building and the earthquakes will also happen because of these movements. And the heat source for this plate tectonics is the primordial heat that is present during the earth's formation, and the radioactive decay of the various elements present in the earth's core region, uranium, thorium and various potassium. So because of the radioactive decay of these elements, the plate movements are happening, plate tectonics are happening, right? Okay, so this is the asthenosphere. The first one is what? Lithosphere. After lithosphere we can say the asthenosphere, and then the mesospheric mantle will be there, and then the outer core and the inner core region. And Moho discontinuity is the one which is the dividing between crust region and the mantle region. And now we will understand regarding the concept of mantle. So under the asthenosphere, then the under the asthenosphere or under the crust, we can say the mantle is present, right? So immediately after the crust region, we can say there is mantle. So mantle extends from the Mohorovicic discontinuity. It starts from the Mohorovicic discontinuity. And when we talk about the density in the mantle region, the upper mantle is having 2.9 to 3.3 grams per centimeter cube. That's the density. And the lower mantle is having 3.3 to 5.7 grams per centimeter cube, the density. And when we talk about the composition of this mantle layer, 45% of oxygen will be there, and 23% of magnesium will be there, and 21% of silica. So silicates which are rich in iron and magnesium, that is more than the crust region. And there is a high temperature that is present in the mantle region, and because of which the ductile silicate materials will be present and convection currents will be happen. So what is the meaning of this ductile silicate material? Mantle rocks are solid in nature, but because of the heat that is coming from the core region, they becomes ductile, right? That means they become, the rocks which are present in the mantle, they melt because of the heat that is coming from the core region. They are almost solid. The rocks which are present in the mantle region are almost solid, but not like the rocks that are present in the crust region. Okay, they are semi-solid in nature. And from where this heat is coming? The heat is coming from the core region. That heat is helping the melting of the mantle rocks. Okay, so at surface we have rocks are there, they are very hard and brittle, But inside mantle, what happens? Because of the temperature is very high, and because of the heat also, pressure also increases, right? As we go deep into the earth, rocks are still technically solid in this mantle region, but they behave like the chewing gum or the hot wax, and they bend and flow slowly instead of just breaking, and that property is called as the ductility. So instead of just breaking because of the heat and pressure, they will simply melt like a hot wax. Okay, and inside the earth, heat is constantly moving outward from core region to mantle region, and from mantle region to crust. And where the heat in this core are coming? Because of the radioactive decay of minerals present in the core region. So when any material gets heated, what happens? It becomes lighter and it will expands, right? And it will expands and rise upwards. So the same thing is also happening in the mantle region. Okay, so what is happening in this mantle region? When because of the heat that is coming from the core region towards the mantle, the rocks which are immediately present above the upper core region will start melting and becomes lighter, and they start move right, and they will start moving upward. So let's say this is the core region, right? And because of the heat, the rocks which are present here in the mantle region will start melting, and because of becoming lighter because of the heat, they will become less dense and they will start moving upward, and the colder rocks which are present already here will move towards the lower region. And this complete cycle is called as the convection cycle that is happening in the mantle layer, right? And this is a actual driving force behind the plate tectonics. Okay, so while this is moving in this way, right, the earth crust plate which is present here will actually be pulled like this, pulled in this direction through the mantle convection cycle. That's one of the factors for the plate tectonics, right? So this upward and downward motion continuously forms a convection current, and convection currents in mantle. So the hot ductile solid rocks, silicate rocks in the mantles slowly rises upwards, and when they reach near the crust region, they start cooling and sinks back down. This creates a giant slow motion circular flow which is inside the mantle. So why it's matter? Because the convection currents acts like a conveyor belt for the plate tectonics. They drag and move the lithospheric plates, which are upper rigid crust plus the uppermost mantle. So that's why we are having the plate tectonics, which in itself results in the earthquakes, volcanoes and mountain building process also. So this is the core region, and because of the heat coming from the core region, the rocks which are present here, the rocks which are present here will become heat, and they will expand and they will travel upward, right? And suppose, let's say this is the lithospheric plate, this is one of the plate, and this is another one, this is the another plate. So because of this convection cells, what happening? This these rocks are pulling this plate towards this way, and the other side, this layer is pulled away, this plate is pulled away by the other part of this convection cell. And after moving upward, the mantle rocks, the mantle semi-liquid rocks, when they reach the uppermost part of this mantle layer, they will become cool, and they will again start coming towards the core region, which itself will form a complete convection cell. So that is regarding the convection cycle in the mantle region. So earthquakes in the mantle are very rare but found in the subduction zones. So after the lithosphere, we will explain regarding the asthenosphere. Lies immediately below the lithosphere. The properties of the asthenosphere is that it is highly viscous, weak and ductile, denser than the crust, and it enables the plate tectonics to happen and allows the adjustment of plates of the earth crust. And asthenosphere is the main magma source for the volcanism. So magma coming from the asthenosphere. So this is the crust region and uppermost mantle. These two are called as the lithosphere, and then immediately below the lithosphere we can say the asthenosphere, right? And the magma present in this asthenosphere is the main source of volcanism. Suppose there is any break in the earth crust and the liquid or the magma, and the magma is coming from the earth crust building the volcanoes on the earth surface, right? So the magma, main source of magma that is present in these volcanoes comes from this asthenosphere. Okay, so next after the, so till now we have understood regarding the crust and the mantle region and lithosphere and the asthenosphere, right? After this, the innermost crust, mantle and the core region. The innermost one is the core, right, which is also divided into outer core and the inner core. So first we will understand regarding the outer core region, the composition of the outer core. That means the outer core is made up of iron and nickel. So that's why we are calling it also as the knife layer. Okay, knife layer, and the elements are lighter in nature, and the density, when we say, it is around 9.1 to 12.2 grams per centimeter cube, and the outer core is liquid in nature because the pressure is not enough to keep the material that is present in the outer core in a solid manner. So because of that, it is liquid in nature. And what is the main heat sources for this liquidity in the outer core, or what is the main source of heat for the outer core? The compressional energy and the latent heat. So what happens in the inner core? Because of the cooling of the material present in the inner core, heat is released and this heat is transferred to the outer core, because of which more temperature will be there and the rocks present here will be melted. And because of the pressure is not that much enough to solidify the rocks present in the outer core, right? That's why the outer core is liquid in nature. Okay, and the radioactive decay of the potassium, uranium and thorium also adds heat to the liquid nature of the outer core. When we talk about the significance of the outer core region, it helps in the convection, and it also, because of the Coriolis effect, it helps in forming the Earth's magnetic field, which can be explained through the dynamo theory. Fine. And finally, we are understanding about the inner core. It is the center of the Earth, and when we say the composition, it is made up of iron and nickel, and density is the highest, 12.6 to 13 grams per centimeter cube. And the temperature is around 6,000 degrees centigrade, as hot as the sun's surface, and it is solid in nature because of the immense pressure. This pressure is not present in the outer core, because of that only the outer core is liquid in nature. And the special feature of this is it rotates slightly faster than the Earth's surface, and it is too hot to sustain a permanent magnetic field. Okay, so this is regarding all the layers, that is crust, mantle and the core region, right? We have talked about the discontinuities also, right? Present. So Mohorovicic discontinuity present between crust and mantle boundary, and asthenosphere, which is a weak ductile mantle layer. Gutenberg discontinuity is present between the mantle and the outer core region. Layman discontinuity, it is present in the between the outer core and the inner core boundaries. So what are these discontinuities? These continuities represent the changes, represent the physical, chemical or mechanical changes between the layers, from where these changes will start. By that only these discontinuities act as boundaries between those layers of the earth. So that is regarding the structure of the earth. Thank you.